Hey, hello everyone. So good morning. Uh, Today I would like to do some review and maybe uh, we can see some examples. Okay, so I prepare some questions for today and hopefully it can help your study for the midterm. And also after this class, I will also prepare another video for your study and hopefully it can also help. Okay. If you check the Google Classroom last night, I just upload uh, the questions from I think last year and I think last 2 years. Yeah. So I thought that would be helpful for you. And you can also watch the yesterday class. We also have some review. Okay. And I also will share this video today with the other class as well. Okay. Okay, so I hope you guys already scanned the QR code. Yeah. Okay, now let's get started. Okay, to start with, I have this two limit. Okay, I have this two limit. So let's see how you can solve this one. This is two questions. Okay, so A and B. And let me give you a few minutes. No, Jordan, later. Okay, later. What's number first question? Anyone solve number A? Okay, number A. If you look there, there is sign, right? And if you think that the sign value is between -1 and 1 always, right? So you can use that comparison, right? Anyone got the answer? Okay, if you look at number A, you can think this sign of sign. This is always, its minimum value is always from -1 until 1. If you multiply with the uh, absolute value, I just say I'm using absolute value to make sure that it's available everywhere. When we have limit, so by squeeze theorem, limit 0. Okay. That's the number A. Okay, if you look at number A, okay, if you change the questions, for example, you change the questions and make the limit not approaching 0 but approaching infinity, what will happen here? If you check the limit, okay, if you check, so this is infinity, this is 0, so it's 0, infinity. So it becomes in the 10-minute product. Okay? I think if you just use, just look by looking at the first question here, if you check the limit, okay, if you check here, um, because it has sign, it has some restrictions for its maximum and minimum value, right? So it suggests that just from this structure, it will force the functions going to be 0. Okay? And the Sukli's theorem here is just to prove that it is confirmed that, okay, it's going to be 0. So um, if the question is in the exam, okay, if in the it's in the exam, okay, uh, if the question is uh, need to be explain, then you can explain by this squeeze theorem. Okay. If this is just a multiple choice, then you can maybe like a short explanation, just use by squeeze theorem, and you choose your options. Still okay, still got full point. But if it is like in a, you need to provide all the steps, then you need to provide this and then use the some as a summary. You write by squeeze theorem, then the questions become zero. Okay, the complete answer. Yes. But if you have this question, okay, let's look at the question again. If you change the x into infinity, if you check, then it will become the indeterminate product, in which we need to force these equations to become 0 over 0 or infinite over infinite, and then we can do L'Hopital rule. Okay. Okay. If you force L'Hopital rule at the first one, it doesn't apply because it's not indeterminate. Okay, it's not indeterminate form. Okay, so you can force the L'Hopital rule. Okay, let me just make some uh, remarks this in this first. So sine, and then this will be 1 over x. I will write x minus. So you can do L'Hopital rule. And I think you can check the answer at the end. The answer, I think, should be also uh, infinite if you check the answer. Because of the chain rule, the 1 over x, it will become the another negative x with negative power, right? At least. And the bottom will be higher than the top, then I think it should be getting 0. Okay. Now let's just look at the number B. Okay, number B. I believe you should be able to solve this. Okay, this is just a normal limit situation. Okay, when you calculate this, careful with the negative infinity. Okay, this might confuse you on the calculation. Okay. So what's best for solving this? I think because it has, at least you see 2 elements, right? This elements x and the element on the square root. Okay. You can take some rationalizations. Okay. You can multiply with the negative part over the same structure. So let me write here. Du is the question. Limit x squared plus 2x minus 1 plus x. Okay. So I'll multiply this with, okay, so the first one is just taking x squared plus 2x minus 1. So this will be, let me write here, x squared plus 2x minus 1. And then it will cancel nicely, right? This plus this and minus this one, this will cancel out nicely, and you will have minus x squared. So it's become 2x plus 1. So I can write the top equation become, okay. Okay, now to help you avoid mistake on plus and minus sign, see this is negative, okay? Probably this negative will affect the positive and negative sign, right? So what's the idea? The idea is we need to change the x into something with negative. So let the wait. Anyone asking? Okay. Yeah. 2x. Oh yeah. Okay. Now to make it easier to follow, let make maybe t or any variable you think this is equal with uh, a negative x. So we change all to negative t. Okay. So we change all, and then because we are using the negative sign here, then our negative infinity is become just positive infinity. Okay, this is to just to help us evaluating the limit. Okay, because if this is just a positive, we can imagine how to divide by the large number of x, the highest degree, right? So we are going to have this limit becomes x approaching just positive infinity, and all the x will be changed to negative t. Okay, the negative t squared is positive t squared. Okay, and 2x become negative 2t, negative 1, and then negative x become plus t. I think this and then this will be t. Okay, now we can solve this. Let's divide or maybe multiple with 1 over t, 1 over t. Okay. 1. Okay. So this will be 0, 0, 0, 0. So it will be negative 2, negative 2. this is 1. So negative 2 over 2, negative 1. Right, right. Okay, any questions from here? Any questions? Okay, not. Uh, Let me give some time for students who just come for scanning the QR code. Okay, so please scan the QR code. Okay. Okay, this is the next question. There are two questions within this one big um, information. So let me maybe zoom in a little bit. Okay, so you have a function, two equations, sine squared ax over x when x is positive, okay, and absolute to x plus 1, absolute to x minus 1 plus b cosine x when you have the x is negative. A, b is a constant, and that is the one you need to find. What values of a and b uh, when the function is continue at x equals 0. And the second one is the same question, but the function's differentiable at x equals 0. Okay, so differentiable means first, the function needs to be continuous, and second one, it should be fit with the definition of derivative in limit. Okay, if you remember. So first, A, if you get correct, then you'll be able to solve the next one. Okay? So first is continue. Okay, so you need to imagine the 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 equation here is continuous. Okay? So you need to have the limit from the left and from the right should be the same result, right? And it's not saying if they are zero constant. So you need to make some conditions. If one of them is zero, what happened when one of them is not zero? What is happened? So you need to have some conditions in your calculation. Okay, we can check each equations. We can check each equation. So if you have the limit from the right, so this will be the sine squared. So limit, or let me just write one by one. Okay. Let me write the sine with the bracket and then squared, and then it's over x. It's equal, the one to the left is 2x plus 1. Let me just write the whole equation. 2x plus 1 minus 2x minus 1 plus b cosine x. Okay. And this will be 1 minus 1 minus 1 plus b cos 0. And this is b. Okay. The one on the left, if you want to solve this, I think if you see this, the form, sine with some x variable here with over x, you can rewrite this with the sine x over x equals 1. Remember? Okay. Let me write the notes over here. Whenever you see any form that is, maybe you can rewrite the form and make it into this form. You can you can have the one as a result. Okay. So when you look here, so sine, it is actually sine divided x. Uh, there is nothing here, right? So the idea is you need to multiply something with x here, and you need to multiply with uh, so you need to multiply with, you need to have a x, right? So a squared x, and then you need to multiply the top one with a squared x. Do you get it? Okay. So this one here, let me move here. This is limit. So this will be becoming 1. Okay, becoming 1. So I will have this equations. Okay. But I still have limit x, right? So b will be 0, right? Okay. This is if a is not 0. And I think if a is 0, it will be same case, that is the f of x will be also resulting 0 for the x positive, so that you can have 0 and b is also 0. So a can be all real number and b 0. So you have two conditions. But the important thing is this one, okay? This one here, the continuity, this continuity here, okay? Okay. So whenever you have to find a continue at a certain value, that means you need to do the left limit, right limit, okay? And the second question, differentiable. So differentiable means it should be continuous, and also it should be fit in with the limit definition of derivative. Okay. If you remember, okay, the limit definition of derivative is, let me be a little bit right here. One of them is this. I think we can take this and we can approach this one to make it differentiable. So this means, it means we can take also the limit from the right of this limit definition. and it should be having the same value for differentiable. Okay. Okay, so from our question, again, with the similar way, we can fit in our equations that is from the right approach, from the right limit, fit into here, and from the left limit fit into here, and we shall see how it will be, how the results will be. Okay, so limit x positive f of x. This is f0. This is just x, and equal limit x. This is negative from the left. This is f of x, f0, and this is also x. Okay, so let's substitute with the functions. The right is sine, right? The sine a sine sine ax. And let me square this, and then this will be x and x squared, right? Okay. And then this will be a limit x from the left. This is 2x plus 1 minus 2x minus 1. And the absolute value, okay, if you remember absolute value, if you have just one equation absolute value and you try to approach from the left, approach from the right, it will have different meaning, right? But here it seems that because the other way around is the sign, this absolute value is not really that much effect to the equations, except it's just making the one that is inside here. If you plug in some numbers, it will be a positive. Okay, it will be a positive. Okay. So you just take this and approach as usual. Okay. Okay. Now for the sign one, we can a similar method. Okay, similar method. Limit. We need to have sign and we need to have a here, right? The a squared, right? So we need to multiply with a squared here. Okay. So or let me write in maybe here a squared. This is a squared. Okay. So this will resulting a squared multiplied by 1. Okay. And the limit here, if you check, this will become, just take the positive one. So 4x over x. Okay. So this will be 4. So a will be plus minus 2. And again, if a 0, f of x becomes 0, for x positive, and limit of x positive, this will be 0 and equal 4. So this means that a plus minus 2 and b will be 0. Okay, and sometimes, this type of question is actually comprehend all the chapter 2, some of the maybe also chapter 4. Okay, sometimes when you have limit, you can also uh, you can solve by some of this type of questions, and it can be solved by the L'Hopital rule. Okay, so in one question, okay, usually it has, if you look here, the question, this is just taking continuous and differentiable, and some other type of questions with this kind of arrangement, maybe it will have like C, D, E, and all is related to the equations, and you need to solve at least the first or second one, okay, to get the idea for the third one, fourth one. Okay, maybe the other one is taking for another approach that maybe it's not um, talking about continuous and differentiable. Maybe there will be another question as well. Okay. 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 Any questions first? Any questions first? Yes. The first one or just the second one? This is the first one. Okay. The first one is about the continuity, and the second one is about the differentiable. Wait. Mm-hmm. Oh, this one. Oh, here. Okay. Mhm. Yeah. Which one? You mean this? Yeah. If we have limit and this still have the limit for x approaching 0. So whatever a you have, okay. For example, a any real number, then you can have, when you take the limit, you can have b is equal 0. In other word, uh, if you have a 0, it's actually having the same results for a for all real numbers. So b is also 0. And I think, okay. Oh yeah, the second one, b is 0 is from the original equations. Let me write the original equations is, let me write here, 2x plus 1 minus 2x minus 1 plus b cosine x. Okay. So when you look at this, this should be, so this is the f of x, and f of 0 is 1, this one right here, 1 minus 1 plus b cosine 0. So what this b0 means is it's from this f of x, it should be 0. So go here. So that means that because the result should be if A 0, okay. So if A 0, then B should be 0, right? Okay. 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 What's the next one is uh maybe that's this one. So this is the implicit problem. The assumption for implicit is y should be equal for of function of x. Okay, whenever you forget the sign inverse, okay, sign inverse, you can always check and try to build your own formula from this triangle here. So let this is y. So you have sine y is equal x. So the y here x. So this will be 1 over minus. So differentiate this. Differentiate this, and this will be cos y dy dx 1. So dy dx is 1 over cos y. So we get that the sine inverse is this terms here. And that's if you forget. Then we check. Maybe let me write the equation here. This will be 1 over square root 1 minus y squared squared. And then we need to differentiate the inside one. And this tangent will have 1 plus xy squared. And then also we need to have the chain rule one. So I think some process should be done. Okay. Now the y over x we can solve by a quotient rule. It takes some writing for solving this. So dy dx. Or maybe to make it simple, let me just write y prime x minus x prime y equal this one. This will be x y prime plus y. Yeah, some calculations and not easy number. Okay, anyway, check the number at square root of 2 and square root of 6 over 2. Okay. So this is x and y. So exchange all with the number. Let's just change. Six over 4, 3 over 2. should be this will be 3/4 y prime to y prime this will cancel nicely with this, right? And this will be 4. So 4 should be 5/6 square root of 3, right? Yes. Do you get the same answer? Yeah. Okay. Can you help me check my calculation? Do you get this? Correct, right? Correct. Okay, okay. Okay, so oh god, what is the questions? The tangent of tangent line. Okay. Tangent line then so add square root of 2 square root of 6/2 uh, the y, and the slope is 5/6 square root of 3x. Yeah, you can just stop here and this will be the tangent line. That's okay. Okay. Uh, if the question is asking the normal line, then you need to reciprocate the slope, the tangent, and multiply with -1. Okay. If the question is asking normal line, if asking normal line. And let's me. Let's, okay. Okay. So I think the important thing here is the technique for for the implicit. Okay. So every time you have the y, okay, don't forget to derive y becomes the y prime. Okay. If x is just it's just become one, right? So but y should be having a y prime. So for example, okay, sine inverse, it should have the normal or the regular derivative is just if just x, it would be 1 over square root of 1 minus x squared. Okay, so you change x with this whole y over x. It's wrong. Sorry, that's why I'm not getting. It should be okay. This is to make sure. Okay, to make sure that this is the same form. Okay, and then multiply with the chain rule of this y over x, which is this is the quotient rule that we can have the another form, and then the tangent inverse is 1 over 1 plus x squared. So x squared we exchange with the xy, and then the xy we derive becomes the product rule. And then uh, so if you are able to solve from the original equation into the implicit, okay, this is the if it is in the for example if this is 100 point, this will be at least 60 this one, and the calculation will be the rest. Okay. So if you get this correct, you are at least getting 60 or 70 at least 60%. And like from the previous questions, if you are able to just showing that the principle of limit, the continuity, differentiable, you already have at least 40 to 50% before you try to check the what's the limit is. Okay, so that is I think I want to not only you need to have just good result, good answer, but you also understand the process. Okay, so make sure you make the necessary steps like solving this. You are showing that okay, I need to derive this, become this, or this, and you write the result here. It's already a great percentage for the question. Okay. Okay, let's see the other question that I have. I think this is uh, I think not too difficult. I think. So you have a cone, and then with certain information, radius, height, it has also the rate. Okay, and it's lowered to a cylinder with radius r, and it has a water. Of course, you have a cylinder, you have a cone. It's too small, and it says there's a water here, and the water will be. Let me maybe the water is maybe increasing. Okay, maybe this is the increasing level of water. Sorry, not really good drawing. This is I. This is R. This is the cylinder. Yeah, I hope you understand what I'm doing here. Okay. So when you goes inside the water, the cone, uh, imagine that is this is the original cone. It has the certain x distance within the cylinder, and the cylinder also have the radius r. Okay, so I imagine that if I take the relation between r h and this the big capital with the x, I can exchange the r, okay, with the with small r over h, and this is should be square. Sorry. So I can take this and make it x squared and x. Okay. So this is actually from the volume from the big R, pi r squared. Okay. Should be pi. Sorry. You so the pi r squared x. Okay. This is imagine the cone is inside the water. Okay. So it has the additional r. So this is actually if we are looking at, okay, and then find the dy over dt, and you need to take this with relations to the x over dt. And this should have the relations with this small r and the big R squared. Uh, take the general. Okay, so I think I need to check again these questions. Okay, anyway, I will check again and make sure I make another explanation about this question. Or anyone has an idea to solve this one? Hmm. Hmm. What What do you think? Oh, this is apply that is when the cone is underwater. So when the cone is underwater, uh, it's implied that it has uh, additional volume from the water, and I make the additional volume is from the like a stretch from this h and which becomes x, so that the new height will be the x, and then I exchange the radius that is in the cylinder because of the volume addition. Okay. But I think I need to check whether my assumption is correct or no. Okay. That's my assumption. Or anyone has the better idea? Okay, anyone has a better idea? I think we can skip first this one. Okay. Well, I will check again whether it is because I think we need to have one more assumptions to make this correct. Okay. So so I think we need to have at least one or two informations that we need to have, or we need to take some assumptions. Okay. For example, if the cone when inside the water, it should have uh, the volume should be at least when it's underwater, we have additional volume, right? And we need to make some assumption. Okay, I need to check this one again. Okay. Hmm. Yeah, this is uh, the this uh, the rate of the cone. A cone, blah blah blah, lower point first at a rate. Okay, so when it's lower, the rate will be 1 centimeter per second. I think that is the so at the moment when the cone is putting inside the water, the cone is at the rate of the 1 centimeter per second. So I think 1 centimeter per second is we can imagine maybe we can make take the h, maybe the height of the cone. Uh, yeah, maybe. Yeah, but I don't think it's the volume. Yeah. Okay. So I think I need to check again this one. Okay. And maybe check which assumptions we need to take to make our calculations correct. Okay. Okay, let's just skip this one first. Okay. Okay. Let's just check this one. Okay. It's similar to the first one, the first problem we have. So we need to see this question. Okay. Suppose you have the functions f differentiable and 1 to 1 on some interval from -1 to 1. Uh, f prime, the first derivative is 1 plus f squared of x. Okay. Limit x approach 0, f of x over x exists. Okay. Find the f0 and find the limit of f of x over x. Okay, so it's a little bit tricky. Okay? It's a little bit tricky. So you need to solve a b, at least a b to understand c, d, and e. So you need to at least solve this a and b first. Okay? So first, see the f is differentiable. Okay, and you have the equation of the first derivative. And the important thing here is the limit of f of x over x is exists. Okay, it's just saying it exists. So, which means if the limit exists, we can assume that limit has a finite result. Okay, we can assume with any number we want. We can assume with, let's say we can assume with a, with l, with m, right? Okay, so first let's write that assumption first. Because limit exists, so let the limit as x approaching 0. Let's say we have resulting an L. Okay. Now, if we are going to check the f0, because f is differentiable, right? Differentiable on this interval, then the conclusion is f should be continuous, right? For differentiable, so f should be continuous. Continuous means at x equals 0 for that function is equal with the limit of x. Okay, so this should be our uh, our assumption, and then this is, I think, already correct, that f is differentiable, because differentiable that the f should be continuous on the interval, so that at x equals 0, it should be equal with its limit. Okay. Okay. Now I can write here, right? Okay. So that the limit, we know it exists some L, and we multiply with x, so we get 0. Okay. And in calculus and in our condition here, that is applicable, that we can do that. So we can have that is 0. Okay. And remember, f is differentiable, right? F is differentiable. So that the limit, we can think the derivative with limit definition is which is the limit of, right? And this is should be equal with the derivative itself at x equals 0, right? Okay. So our question here for the limit f of x over x is actually our derivative, right? our derivative. If we look at the definition from the limit definition here, and we already arrive at the conclusion that f0 is 0, so 0, and is 0. Okay, so f of x over x, we have this limit that is equal to the first derivative. Okay, and the first derivative, we already have the information on the question, right? Okay, let me write the information. We know that it's differentiable, that is this. Sorry, this. Okay, so f prime x is 1 plus f of x squared. Okay, so f prime 0 is 1 plus f 0. So f prime 0 is 1. Or to be complete, this is limit as x approaching 0 of f of x over x. Okay, that is just A. B, show that the function is increasing on the interval. Okay. So first is look at the f prime x is always 1 plus f of x and then squared. Okay. If you look at the form here, this is always positive, right? So you can just say that it's always increasing. So that's why the functions is increasing, because the first derivative show the slope is always positive, right? So this is show that the slope is always positive. Thus, the function is always increasing on, and then it's also asking about the concavity. Okay, concavity is the second derivative. Okay, concavity is using the f prime test. Okay. How do we get the concavity? We take the derivative of this f prime. Okay, we take derivative, this become f double prime, and we may have some calculation over here. So f double prime is so 2f f prime, right? So we need to find where the f double prime is positive, f double prime is negative. Okay. But since f prime is always positive, then the one that is uh, particularly important here is the sign from the f, right? Because it's always positive. So if the f is negative, then it will be negative. It will be f is positive. It will be positive. So it will be changing the concavity upwards and downwards because of the f. Okay, because f prime is always positive. Right? So if maybe right here, if f less 0, Then concavity means this is concave upwards, this is concave downwards. Yeah, or you can just write concavity. Concavity. Yeah, you can write the words, okay? I don't have space here. Okay. Prove that blah blah blah, and the other one here. Okay. I think the first one is important to prove the second one. Let me make another page. Okay, so we need to prove. Let me write the question. Prove for x at the interval of 0, 1. Okay, so first that is our conditions. Okay, but to solve this, we need to take another assumption for another function. Okay. So we need to prove that this will be a, a, a positive. Okay. Okay. We have proved that f0 is 0, right? So that when we have h0, this will be 0. And then when we have the h prime, the derivative, this will be f prime minus 1. Okay. We know the f prime is uh, from the conditions here, 1 plus fx squared. Okay. This will be 1 plus fx squared and then minus 1. And this we have f of x squared, that is our h prime x. So we from the h prime, this means that the slope of this h is always positive. Okay, that means that f of x is always greater equal x. Positive or increasing. Okay, increasing. You can also write increasing, positive. Okay. And same way for the other proof, proof f of x. What is x? X plus x cube. We can let some other functions that is maybe g of x. f of x minus minus. Okay. And same way, then we can check all the conditions. So when it's 0, then it's equal f0, and it's all will be 0. So we have 0. Okay. And we check the g prime. This is f prime x minus 1 minus 3x squared over 3, or minus x squared. Okay. And the f prime we can change to f x squared minus 1 minus x squared, or we can write this simply becomes f of x squared minus x squared. That will be the g prime. So, okay, so because uh, this always increasing, okay, and we are remember that we are proving this on the interval of 0, 1, okay, on 0, 1 interval. So when you have the f of x squared minus x squared, it's also increasing, okay, because f of x is uh, f of x squared always increasing. Okay, so because f of x squared always increasing, so at interval 0, 1, g of x is increasing. So f of x minus x cubed over 3 of g of x is always that's just to say greater than the g0 for x at 0, 1. You can also write the same thing here. I forgot to write this is okay. Number D is f inverse. F inverse prime. Anyone remember how to find this? The derivative of the f inverse? 1 over the f derivative. Okay. So 1 over f prime f inverse x. I think I already explained, right? One time in class. So this will be 1 over the f prime is 1 plus, what is 1 plus 1 plus 1 plus, what is 1 plus f of x squared, 1 plus 1 plus f inverse x, and then this should be squared. f f inverse x, right? Okay, so this will be 1 plus x squared. Okay, so what function is this if we have this? It's related to the tangent that we solved, right? Okay, so from the result, f inverse is a function whose derivative is, and we know there is possibly possibly one function that is tangent inverse x. This is number D. E. So the f inverse of x is tangent x, and the f of x is tangent tangent inverse. Sorry. Okay. Okay. I think if you'd like to check your also answer, there's one more question here, but I think you can just take some notes and check yourself by yourself. Do you think the questions stay difficult? Because yeah. I thought the advanced one. So maybe in your exam there will be like a difficult question and a relaxed question, so will be balanced. My suggestions: if you think you are going to have a lot of time doing that kind of questions, skip that for a while. Look for the other questions first, and take for some time for the other one later on. Okay. And usually, when I do the exam, I will give at least estimation for the points for each number, so you can think which one you think you can do first, that you might have a correct answer, and you need to do it first. Okay? If you think that okay, maybe I cannot solve this one, skip it and find the one that you are saying that the point is good, you can do it. You do it that question first. Okay. Okay. It's kind of like optimization of your score. Okay. Okay. I will prepare another video to help you to solve. Okay. Several problem. You can also check your exercise. Okay. Some of the problem will be come from exercise as well. Okay, I think this will be the end of our class. Okay, there will be no feedback time for today's class. Okay, any questions from the online students? Any questions? If there is no question, so see you on midterm. Okay, see you on midterm. Yeah, you're welcome. Rebecca.